Hi students, welcome to HSC Earth and Environmental Science and Module 5, Earth's Processes. This is our final video for this particular module. We're going to be looking at mass extinctions. This is the second half of our previous video where we were looking at evolution in the Cambrian and some of the important principles in geology such as uniformitarianism, superposition, fossils like index fossils and absolute dating, and how each of these can be applied to major events of geological significance. So we looked at evolution of Cambrian fauna in the last video, and this time we're going to look at mass extinction events. So important, I guess, to be able to, again, make sure that we understand some of these different types of relative and absolute dating methods to be able to apply what we looked at previously now in the context of mass extinctions, and maybe have a little bit of a look at some of the potential causes for some of the most significant mass extinctions in the fossil record. When we look at the fossil record, we see a number of occasions where there's a change in the faunal assemblages, there's a change in the fossil assemblages as we go through different layers within the Earth's crust. And this suggests to us that there's been a number of different occasions where we've had some significant geological event, or at least some significant event that's been preserved in the geological record from long ago. When we start to identify some of the changes that have occurred, it suggests that there's probably 5 major extinction events, with potentially a 6th one that we're actually going through at the moment. But that's something we'll look at later on in the course. For this particular video, I want to focus on 5 main mass extinction events and really, I guess, start to have a look at some of the evidence, or at least some of the ways that we can apply some principles to what we know about these significant events. So I guess the best known one is the last one on this list, which is the KT, or Cretaceous Tertiary boundary. And it's probably the most famous because it was the time when the dinosaurs last walked the Earth. It was also one of the ones that's been quite well studied in terms of asteroid impact. So there's a couple of different pieces of geological evidence that support that, and that we'll actually have a look at in this video, at least briefly. But that was an event that probably resulted in about 75% loss of species numbers in that sort of period of time, around 66 million years ago. There was a worse mass extinction. The worst mass extinction that we're aware of was at the end of the Permian into the Triassic, so the end of the Paleozoic into the Mesozoic. This was between 90 and 95% of species that just got wiped out at this particular period. And so that's very significant. But you can see from these others, Ordovician, Silurian, late Devonian, and the Triassic, Jurassic extinctions, still between 60 and 70% loss of species. So this is a massive shift. And I guess the first thing for us to think about is, how is this likely to be reflected in the fossil record? What are some of the things that we might notice that would tell us where we're getting to the end of the Permian into the Triassic, from the Triassic into the Jurassic, and so on. So just as we did previously, I've set up a little table here with the specific strategy that we might look at using and the outcome, and how we might apply that to the dating of mass extinction events. Now, obviously, this is a simplified table, and one of the things that we'll do in class is to actually expand on this a little bit. In fact, it might be worth having a focused case study of one particular mass extinction event, and then going through this and having a look at exactly what sort of evidence there is. I've tried to focus a little on the KT boundary, the Cretaceous Tertiary boundary, just because it's probably one of the best known, and it's something, I guess, that we can try and draw in some particular areas of evidence. But in order to give you an example of each, I've mixed it up just a little bit for you. Firstly, the principle of uniformitarianism. Now, you remember from the last video when we were talking about the Cambrian fauna, one of the important things that we were looking at there is that whole Darwinian gradualism versus the punctuated equilibrium model, that sort of catastrophic model. And that's George Cuvier's model. Changes occurred rapidly in very short periods of time, and we see these reflected in the fossil record. And that contrasts with this idea of uniformitarianism, which is just steady, slow, gradual changes. Now, we did look at the fact that the Cambrian fauna can be explained at least in part due to the massive changes that were occurring both in terms of evolution itself, in terms of the changing nature of some of the different organisms and some of the structures that were helping them to become more effective hunters, or more effective at evading hunters. And so a lot of important pressures are all happening at the same time, really driving that process of evolution and happening at a much faster rate than usual. But we can see that there are certainly some rare catastrophic events that have been reflected in the fossil record, and mass extinctions is really kind of that big area of where we see some catastrophes, some massive changes, and we have to try and figure out why these things might have happened. Of course, there's two things to keep in mind here. Firstly is that there has seemed to be a little bit of regularity around these sorts of mass extinction events. We haven't had just one or two, we've had a number of them, and they do have similar kind of catastrophic events on the organisms that have been present on the Earth at the time. But then we do see little periods where each of these events has actually given rise to an adaptive radiation. So a group that maybe may not have emerged had conditions remained the same, but with that change, with that considerable loss of not just species, but also the availability of niches just opened up, and so species then radiated that very quickly to fill those niches. And so there's a logical progression between these mass extinction events and these rapid evolution events, particularly around adaptive radiation that we see happening after each of these. So, for example, the death of the dinosaurs led to a radiation in mammals, and certainly they filled a lot of those niches that were previously occupied by some of the dinosaurs. So that 75% species loss did actually open up the environment to a species, or at least a group, that could take advantage of that, and that certainly was the mammals for that particular one. Superposition, remember, is about different layers, so we're looking for different layers here. And of course, one of the things that's really important is if we see a certain number of fossils and we know that they're all present in a particular layer of rocks, and then above that, for whatever reason, there are none, then that's kind of suggesting to us that something must have happened from one to the next. Of course, these sorts of things look instantaneous in geological time, and we know geological time is very, very big. So it's a scale that's different to what we're used to thinking about. But certainly there do seem to be rocks that are dominated by certain groups, and then these groups just seem to disappear from any of the rocks above them in the younger direction, so going younger as we go up. When we start talking about the principle of superposition, it's very difficult not to also talk about stratigraphy, because we are talking about layers, and we are talking about often geographic distributions, looking at how abundant certain organisms were around the world, and also whether or not the disappearance was a localized event or more of a global event, whether they just all disappeared from around the world at the same time. And of course, that's one of the things that draws all of these mass extinction events together, is their global impact, as it were. So sudden appearances or disappearances of groups in rocks that are above or below is suggesting something about maybe a major event that occurred at a certain time. Some of the different types of minerals or materials that we find in certain layers of rock can also be suggestive. So again, around the KT boundary, we find a lot of different types of evidence that suggests some sort of a meteorite impact that may have been at least a trigger or a significant contributor to that mass extinction event. So some of the things like shocked quartz, tektites, a high concentration of iridium in these layers that correspond to the end of the Cretaceous, beginning of the Tertiary, are certainly some of the evidence that's been used to support this idea of meteorite impact. Index fossils can also be used to help mark boundaries, not so much for the Cretaceous Tertiary. Obviously, the disappearance of the dinosaurs is important, but we do find at the Permian Triassic there's a couple of different conodonts, which are an interesting group of organisms that we know from fossils. that were also index fossils as well. It gave us a little bit of an idea of short periods of time that marked that boundary between the Permian and the Triassic, mostly of the same species that we look at. But while we do find a much larger range of fossils that are not all index fossils, we do see sometimes this massive appearance and disappearance that we've seen in the Cambrian, disappearance that we see for a lot of these mass extinction events. So volcanic ash is again one of the key things that we look for in our rock layers, in our strata, to see if there are possibilities for us to use something like radioisotope dating to get absolute dates for particular things. Now this is particularly important if the rock layer that we're interested in is sitting between two layers that we can age absolutely. So if there's two, say, volcanic ash layers here, again what we're doing is we're relative dating. We can't date that exactly, but what we can do is say quite clearly it's between these two events. So what's happened in age is between these two events. So it gives us a sort of a earliest time, most recent time that we could put together for these sorts of events. And that system has actually worked quite well in identifying some of these very important mass extinction events. But what caused them? Well, again, we're going to have a bit of a look at some of these in class, but this was a really nice little diagram to give you a bit of an idea of these 5 key events and what sort of things might have contributed. So we've talked about the KT event, and we've said that one of the things that we think was fairly significant contributor was some sort of an impact, something coming from space, crashing into the Earth, sending up clouds of dust and all sorts of other things. But what we do find is that there's also some other factors which either might have contributed or helped exacerbate a situation that was already going to be a little bit tricky. So you can see climate is an important has an important role to play in a lot of these different extinction events. And there's a lot of these are interconnected too in terms of the chemistry of the atmosphere or the oceans or the levels of oxygen dissolved. And often these will also relate to temperatures. So if there are changes in global temperatures, global warming or global cooling, this is also going to affect solubility of gases in the oceans, and that's going to have flow-on effects to not just marine ecosystems, but also potentially to terrestrial ones as well. So this is a nice little overview to give you a bit of an idea of some of these factors that can be important contributors, maybe sole explanations, maybe together have created the type of environment that is going to drive certain species to extinction. But this is the end. This is the last video in our Earth processes sequence. We're going to have a look at some of these mass extinction events in a little bit more detail in class. But for now, thanks for watching.